Hey everyone, welcome back to DeepPenetech's Tech Share. Today, we're tackling one of the toughest nuts to crack in high-end manufacturing, deep penetration welding of pure copper. We'll dive into the physics of energy conversion and show you why vacuum electron beam welding, or EBW, is hands down the better solution for highly reflective metals. Here's our game plan. First, we'll look at market demand and pain points for copper welding, then explain why lasers hit a brick wall here. Next, we'll show how EBW breaks through, walk through a head-to-head comparison with real-world applications, and finish with how DeepPenetech can support your projects. First off, pure copper is essential. Thanks to its unmatched electrical and thermal conductivity, it's everywhere from EV motor windings and busbars to semiconductor vacuum chambers and cooling plates. As high-end equipment upgrades, weld quality directly drives performance, efficiency, and lifespan. So why is copper so hard to weld? To start, at room temperature, pure copper reflects over 90% of standard infrared laser light, meaning the energy just bounces off. On top of that, copper moves heat 8 times faster than steel, making keyhole stability a nightmare as heat dissipates instantly. Finally, liquid copper oxidizes in a heartbeat, creating brittle joints that ruin conductivity. This is why conventional laser welding struggles with deep penetration. Most infrared laser energy is wasted, and reflected beams can damage expensive optics. Cranking up the power leads to massive heat buildup, severe distortion, and coarse grains. Multi-pass welding on thick plates is slow and prone to porosity. Even green or blue lasers, while absorbed better, are power limited, expensive, and mostly stuck on thin sheets. EBW succeeds because it changes the physics completely. Lasers rely on photons light radiation, which means reflectivity and surface conditions are constant headaches. EBW fires high-energy electrons. These particles slam directly into the material, converting kinetic energy straight into heat upon collision. You get zero optical reflection, near 100 absorption, and the vacuum environment keeps oxidation completely at bay. Because of this efficiency, EBW delivers several times the depth of lasers at the same power. We're talking single-pass depths of tens of millimeters, so no multi-pass layering is needed. This slashes lead times by over 60%, cuts labor costs, and minimizes filler material. Less wasted energy means less total heat input. The overall temperature rise is minimal, giving you an ultra-narrow heat-affected zone. This preserves grain structure, protects conductivity, and keeps thermal distortion so low that post-weld machining is virtually eliminated. Welding in a high vacuum locks out oxygen entirely. You get clean, oxide-free joints that match the parent metal in strength and conductivity. There's no spatter, no slag, no porosity, and no need for post-weld acid washing, perfect for ultra-clean electronics and vacuum devices. When you look at the stats, it's night and day, nearly 100% absorption for EBW versus under 10% for infrared lasers. EBW wins across the board in penetration depth, thick plate performance, distortion control, and oxidation prevention. For deep penetration copper, it's clearly the superior choice. This technology is already active in high-end sectors. In EVs, it's used for hairpin windings, high-voltage busbars, and cold plates. In semiconductors, for copper vacuum chambers, heat sinks, and RF components. In power electronics, for vacuum switch tubes and busbars. And in advanced tech, for heat exchangers, sensors, and superconducting parts. At DeepPenetech, we specialize in vacuum electron beam welding. We have high-power EBW systems covering everything from 0.1 mm foil to heavy copper plates. We also maintain tested, proven parameters for pure copper, brass, beryllium copper, and more. From R&D samples to mass production, we offer end-to-end certified service, backed by UT or PD testing and conductivity checks. To sum it up, EBW trades photon radiation for kinetic electron bombardment, overcoming copper's reflectivity at the physics level. You get deep penetration, high purity, and minimal distortion. If you're facing deep penetration challenges with copper or copper alloys, reach out to Bingpeng Tech for process consultations and sample testing. Thanks for watching.